Alright guys, so today in algebra we're going to look at prime factors in GCF. I know in class you guys always want to wear a hat, have your phones out. Today you can wear your hat and watch this on your phone. So there you go. Hopefully I'll be quick and to the point here and try to help you guys out for the worksheet. Alright, so for the notes for number 1, we're going to look at prime factorization. So first of all, remember prime numbers are numbers in which we have the only factors of that number are 1 and itself. Okay, so for instance 3 or 5. 2 is the only even prime number. You can go up to something like 17. There's no numbers that go into 17. However, 1 and 17 are the only factors. 16 is not a prime number because you got a whole bunch of factors that go into 16. All right, so here we go. So if we have 56 y to the third, we're going to break this down into the prime factorization. So basically we're going to use a factor tree. So we can use any factors of 56 that we want. You might use 2, anytime it's even. A lot of times students want to use a 2, but you can use any factors that pop in your head. So for me, I think I've got 8 times 7. All right, and so off of 8 times 7, we can go turn the 8 into a 2 times a 4. 7 is a prime number, so we keep it, right, like that. Now, we're not quite done because 4 is not prime. So then we go again, this 2 comes down, the 4 turns into 2 times another 2 times the 7. So there's our prime factorization of the number 56. Okay, now off of that, we also need to take and write out the factors for y to the third power. So that's just going to be y times y times y. So this would be our prime factorization of 56 y to the third. So your quiz should match up with this, or your homework assignment should match up with this. Well, another way to write this is 2 to the third power times 7 times y times y times y. You might see it written that way on some multiple choice tests. Okay? Feel free to pause at any spot you want to see. Hopefully all this comes through clearly. Obviously it's the first time running through this, so I'll make adjustments this week as we go. Okay, for number 2 in the notes today, we're going to have we're going to find the GCF of 42 and 18. All right, so the GCF stands for greatest common factor. All right, so we're going to talk a lot about the greatest common factor here in the next few weeks, as that's a lot of what we're doing here with factoring. So keep that over to the side. Now, as far as the greatest common factor, you can always check the smaller number to see if it goes into the larger number. Now, I'm going to show you the longer way to get it, but there's also some faster ways to kind of use some, not tricks, but just ways of thinking to go about trying to find a GCF that might be faster. So if we do the prime factorization of 42, I'm going to use 2 and 21 this time. All right, and then off of that, 21 I can go into 2 times 3 times 7. So there is 42. Then we go to 18. 18 would be, you can use 2 again, or you can use 3 times 6. So the 3 is prime, and then the 6 we can go into 2 times 3. Okay, so for the greatest common factor, when we look at this one versus that one, we have a 3 in common. We have one of these 3's in common. So our GCF here will be what overlaps, and that is a 3. But then if you look closely, we also have a 2 as well. So the 2 is going to come down here. So our GCF is not just 3, it's not just 2, but it's 3 times 2, which is 6. All right, so don't make the mistake of multiplying this 6 times that 6 and putting 36. A lot of times students will try to do that. Don't want to do that on these. Okay? All right, so our GCF of 42 and 18 would be 6. All right, we're going to keep moving here. You guys can pause at any chance you want. hopefully all this is coming through clear, and like I said, if it's not, let me know via email. All right, next, GCF for variables. So let's say we have a to the third b squared and a squared b to the fifth. All right, so if we're given this, we could write all these out. Okay, like I could write out all these threes. I got 8 of them, or 3 of them, 3 of the a's. I could also write out these. So just like last time, we could circle the ones in common. We have 2 here and 2 there. All right, now the faster way of doing this, if you're going to write the GCF, is just to go ahead and look what is the smaller exponent with the variables. Now this only works with variables, so the smaller exponent is 2. We ended up with 2 in common, so this is a squared. Okay, same thing with the b's. We could write out 2 and 5, but we can't go over the 2, so that one will be to whatever the lower exponent of these 2 variables would be, which is 2. So the b's in common, we can't go over the 2, so the GCF would be a squared b squared. Okay? All right. Let's see. Almost done here. We got 2 more. So again, like I said, you can pause at any point. Okay, number 4. This time we are going to factor by GCF. All right, and so factoring by GCF, and really a lot of what we're going to try to do here is factoring. So stick with this. You'll get better at it. Just take a deep breath, and if you have questions, email me, like I said. Okay, if we want to factor by GCF, if we're going to factor by GCF, we go something like 10x plus 5. Okay? So what we're really doing is the opposite of distributive property. Okay? So this is kind of reverse distributive property. So we look at both terms. We're basically going to find the GCF. So as I was talking earlier, I said sometimes the faster way is to think, take the smallest number. Does 5 go into 10? Yes, it does. So whenever I factor this, the 5 is what's going to be out front of the parentheses. And then to undo multiplication, we divide. So to find out what is left over, we're going to divide whatever this number is back into both. Right, like that. Okay, so now we're left with 5 into 10 is 2x. 5 into 5 is 1. So there is my answer. 5 times the quantity, 2x plus 1. All right, so that is a factor by GCF. We're going to do one more of those and wrap things up for today. Okay, last one, number 5, is going to be 14y squared minus 35y. Okay, so this time we start with 14, and we see, does 14 go into the 35? It does not, at least not evenly. Okay, so we'd get a decimal. So then the next best option, aside from, we could make a factor tree and try to figure this out. If 14 doesn't work, the next highest factor of 14 would be half of it, especially if it's even. If it's only divisible by 3, then it would be whatever that number is divided by 3. But for instance here, 14 is divisible by 7. So does 7 go into 35? Yes, it does. So that's one way of thinking to try to figure this out. You can always go back to the factor tree. Now, do they have any variables in common? The last one we did not. This one has 2 y's and 1 y. So they can't go over whatever the smallest exponent is. So we take 7y out. We're going to divide 7y into both. And when we do that, we get 7 into 14 is 2. All right, now going back to exponent rules, 2 minus, this is really 1. 2 minus 1, we get y. 7 into 35, we get minus 5. And the y's basically cancel out. You could put y to the 0, but anything to the 0 power is 1. There's my answer. And there you go. So hopefully that makes sense. Like I said, if there's questions, email me through Canvas, and do your best to get your assignment and attendance done on time here. I'll be wearing my hat again tomorrow, and hopefully come back with more information for you guys. Hopefully this works. Thank you.